Hello and welcome to Quarkus Insights, episode 8, Mutiny, the reactive library, with a special guest, Clement Escoffier. Good afternoon, evening, morning, night, wherever you are. Welcome. And today we're going to talk about, generally reactive programming, but specifically about a library called Mutiny. And for that, of course, I've got my partner in crime, Max, to try and figure that out because we're not reactive people. But Clement is, and he will, help us decipher the subject. Hello, Clement.
Hello. Thank you for having me.
Yeah, well, we forced you into it.
Well, thank you for forcing me doing this.
Yeah, there you go. Max, you said we had just a couple of subjects before we go into the core of the subject, right?
Yes, well, the usual one is if you want to have an episode of specific topic, go to our Quarkus.io GitHub, and then there's a vote. You can vote up you can vote on the stories that are called Quarkus Insights, so labeled Quarkus Insights. And then the other one is just we talked about last time, but the hackathon for Quarkus was kicked off last week, which is this thing running for I think a month and a half or something. Where everyone can kind of try out if they're building an app, microcoding app, building an extension, that kind of thing. And if you sign up there, there's some money to be had. So the Quarkus Global Hackathon.
Yeah. These are prizes, not quite money. So
yeah,
don't want to make any high hopes. You're not gonna be rich. Oh, there is echo. Okay.
Max's voice.
Say again.
Oh, they just said my voice is robotized, which is weird.
That's happened when I share Google Chrome last time, and I am sharing Google Chrome at the moment. So, but that was the problem on your side the first time.
Hey.
Oh no, It was me. Remember, I forgot to mute something.
Yes.
Or was it system audio? Is it better, people?
1, 2, 3. I'm not a robot. Yeah.
Yes.
Right.
Okay, that should be better. Anyway, so yes, so the Global Hackathon, go to quarkus.io/blog, and that should work. The other stuff that Max was presenting, go to github/quarkus.io/quarkus.io. No, hold on. It's this one. It's not the main Quarkus repo. It's the quarkus.io.github.io repo, and from there you see the bunch of issues, and there is I forgot the label. If we go to labels, Insights is the label you're looking for. Please vote for the subjects you're interested in, and then please, if there is a subject that is not covered, please add it, and we will use our total benevolent dictator rule to figure out what the next subject is, depending on availability of people and so on. All right, so Clement, tell us a bit about yourself before we dive into Mutiny.
So my name is Clement. I'm working from France. I've traveled a bit before going back to France. I'm doing a lot of things around reactive. I'm working at Red Hat, so I'm doing reactive stuff at Red Hat. I did a few years of Vertex. And recently I'm more involved in the Quarkus world and small while world. I've done things around microprofile and reactive, so microprofile reactive streams ops and microprofile reactive messaging. And today I'm going to mention a little bit them, but mostly speak about a new library we have been building for the last 10 months or so, which is named Mutiny, and why we did that, and the difference with the other reactive programming library.
Okay.
Hold on. So that's mostly.
So I was confused. So before we had the conversation into why Mutiny and so on, a conversation you and I had is Isn't Vertex this reactive library already? So what's the difference? We know that Vertex is at the core of Quarkus, so why not Vertex?
So exactly. So Vertex is a core of Quarkus, but it's an engine. It doesn't expose an API. Actually, it's the opposite. Vertex exposes multiple APIs.
Mm-hmm.
So at the bottom, what you have is non-blocking I/O. And the reason you want to do non-blocking I/O is because in the cloud world, with the level of concurrency we are reaching these days, you need to use your resources more efficiently. And when I say resources, I mean CPU, memory, hard disk, and so on. Nothing is free, especially on the cloud. Even if you are on your private cloud, it's actually also very expensive because everything that an application is consuming means less for the other containers or the other applications that are running on the same virtualized host. So we want to use non-blocking I/O to improve this efficiency. What non-blocking I/O means is it's actually relatively simple. You delegate a lot of things to the operating systems that will call you when something is ready to be consumed. So for example, you want to do a request to a remote web service. You say, okay, request this and call me back. In the Java world, there is one non-blocking I/O library that everybody is using these days. It's Netty. So Netty is awesome. It's great. It has a big ecosystems. The tricky thing is that using Netty directly is a little bit hard. It's really low level. It's actually just a level above non-blocking I/O, but it's very hard for bare mortal to develop against it. So, and Vertex is a layer that comes into between these and makes the Netty APIs a little bit more easy to use. It also comes with some different facilities to handle what we call the context, event loops, and things like that. And the event loops aspect is actually key here. If you use a non-blocking I/O, and why it's interesting to use non-blocking I/O in this cloud world, it's because you are going to reduce the number of threads. And by reducing the number of threads used by your systems, you are going to reduce the memory, because each thread takes memory, but also the CPU because of the context switch. So for doing this, what Netty and Vertex are providing is an event loop systems, where you are going to always be called on the event loop. This is the thread that is handling the I/O. And there is a few formulas to compute the number of event loops, but basically you can say that it's the number of CPU cores, which in a cloud or in a container is generally 1. And here is a catch. If your user code, your application code get run on the event loop, you must not block. Because if you block, then that means that these threads cannot be used for anything else. And if you don't block, that means that you get a request, you do your things in a non-blocking manner, and as soon as you cannot make progress, or as soon as you need to wait for something, you release the thread, and something else can be, the thread will be used to handle another request. Okay. So this way you can handle a lot of requests on a minimum number of threads. So Vertex, to go back to Vertex, it's this layer that will make this a little bit easier to do. But Vertex, by default, the API that is exposed to the users is based on callbacks. The advantage of callbacks is that they are easy to understand. It's really, as it said, a callback. So you pass a method that is called when you get the answer. So it really suits well the non-blocking I/O model. The tricky thing is that, callbacks compose very, very badly, in the sense that if you need to do something and then wait for an answer and then do something else and then wait for an answer and do something else, then you already have 3 nested callbacks. And you have some spaghetti code that is not necessarily easy to understand, nested indentations. It doesn't really work well. It's nice for Hello World or for very simple things. It's actually the most efficient model we have, but it doesn't scale in terms of development and code. So, and Vertex is going to provide this callback APIs for the complete Vertex ecosystem, which is huge. I can't remember. I think there is more than 80 different components in the Vertex ecosystems.
Yeah, so that's the other big difference with Netty. I don't know if you said it or not, but Vertex have a higher level, slightly higher level than Netty, but also a massive ecosystem of connectors that are non-blocking. So connect to Kafka or Redis or many interesting
Exactly.
things.
So some of them are actually based on the Netty codecs, and some of them are actually just an implementation or reactive implementation of those clients.
Yes.
But they
Although
are
there
all
is
non-blocking
SQL
or
driver
reactive.
clients, I think MySQL, Postgres, and then what's coming in Vertex 4, no, actually already in 3.1 is SQL Server, and DB2 is on the go. So you got a decent coverage of databases.
Well, it's not only databases. So you mentioned the database, but messaging, so Kafka, RabbitMQ, IMQP, or even a NoSQL database like Redis, Mongo, and so on. The Vertex ecosystem is really, really huge. It can go from IoT gateways to regular microservices, calling web services, building web apps, template engines. It's actually really huge.
So to
So Clement,
accelerate a bit, we have oh, sorry, Max.
I just want one question, just for a noob here. So Mutiny is built on Vertex, or its
no, so hold
library?
on, we haven't answered that
Uh,
question yet. So yeah,
okay, but
We are not
that was
there
why I was
yet.
like,
so
where?
Vertex
Okay,
has
there. Okay.
callbacks, and on top of it, we expose a nicer. The Vertex team exposes a bunch of other APIs. They could be completion stage based. It could be give us the list, Clément. But then
So Vertex is actually polyglot. So even if it's always based on the JVM, but you can use Vertex with Groovy, Ruby, JavaScript, and other language. The most popular these days are Scala and Kotlin. So Vertex provides all the Vertex APIs to all these languages. And then in the Java world, the pure Java world, Vertex exposes a few different APIs. So you mentioned completion stage, but we also have Eric Java 2 and more recently Mutiny. That being said, Mutiny is not bound to Vertex at all. We have all the Vertex ecosystem exposed as Mutiny API, but Mutiny itself is an independent project. We work together to make them fit, it does not depend on Vertex itself.
okay, so these are I'll simplify, but these are the input and return types in a non-blocking fashion. And before we zoom to Mutiny, we had a couple of questions around Vertex and your favorite things like Loom, Kotlin coroutines. So let's have a couple of a quick exchange before we actually shift gear into Mutiny. So what do you guys think about the project Loom and its status on the reactive world in Java?
So Loom
Hop,
is
thrown under the bus. There you go.
no, Loom is very promising. It's going to make the development of non-blocking asynchronous application a lot easier in the sense that you don't need to use a non-blocking asynchronous development model. That being said, it's not a silver bullet either. You will have to do things using reactive programming libraries because there is not the same type of construct. At the moment, so I tried Loom. So the build of Loom I've tried was built end of May. So what I will say right now might be a little bit outdated. So bear in mind with that. There is a few things that still need to be covered. So typically in Loom, so what Loom is? So Loom is introducing virtual threads. So basically in the Loom world, you have a pool of carrier threads, generally the same number of event loop. They are not event loop. And then for inside each of these carrier threads, you have virtual threads, which are like green threads for the old Java developer, let's say, but in the sense that you can have multiple virtual threads on the same carrier threads. So everything is fine. And the great thing with Loom is that virtual threads code, so the runnable you pass to these threads can block. And what the Loom magic here is that it's going to detect that you're blocking and actually keep you somewhere, but release the carrier thread, and the carrier thread can execute another virtual thread. So far so good, except that there is a few constructs from the JVM that are blocking the carrier threads, typically synchronized, wait, object wait and notifies. So these things are still blocking the carrier threads, and there is a few other constructs that are blocking actually. And here you need to be very careful and think that, oh yeah, there is Loom and I will use Loom and I don't need anything, because most of the time you will need to tune a little bit your infrastructure and middleware to avoid all those carrier blocking operations, because that's the same thing as an event loop. If you block the carrier threads, you kill your concurrency. So you really need to be aware of this.
So that means that just to shorten the subject, that means the ecosystem will have to adapt to Loom
yes.
to some extent. Plus, there is the whole data stream aspect, which is not covered by Loom itself.
Exactly. Or typically one thing that is relatively hard to do in pure Loom is to call two remote services concurrently and join on the result. Yes, you can do that by starting new virtual threads and things like that, but then you use futures. If you use futures, well, you can already in the asynchronous world, so it's kind of a little bit misleading here. So I believe that we will still have the two worlds side by side. Okay. The good news, and that's the result of the studies I've done recently, is you can use the Vertex client, the Mutiny version of the Vertex APIs on Loom, and this is not going to block the carrier threads. So,
okay.
So
lots of prototyping still to go for, but that's something we monitor and we keep an eye on. By the way, the performance of Loom at this stage are pretty heavy on the garbage collector, so there is also work to do on that. One quick question I probably can, I'll just address. What is the difference between an event loop and a worker loop pool? So event loop is really where things are supposed to happen in a non-blocking fashion. Otherwise, you delegate to send another event to make it happen. The worker pool is your way to to mix the new world of non-blocking into the old world of stuff that would block a thread. And there's essentially a worker thread that is here to say, okay, you're doing JDBC in a blocking fashion. I'll pass the operations to that worker pool. But it's an old style pool that is blocking if you consume all of the resources and yada yada yada. So it's a bridge with the legacy universe. As much as possible, try not to have to use the worker pool if you try to go for the full non-blocking fashion. And the final question before we go to Mutiny, it's around Kotlin. So any opinion around using Vertex with coroutines using Kotlin? It's the nice, blocking like, but non-blocking like, and then
it's a great combination. It's probably what I will go for these days if I will be efficient in Kotlin, which is not the case unfortunately yet. But yeah, it's a great combination. The coroutine support with Vertex works great. So you can really have nice code and. Yeah, it's kind of give you a flavor of Loom, but yeah, it's Kotlin. But yeah, try it. It's actually very enjoyable.
So Ali is asking, I'd like to see Kotlin coroutines supporting Quarkus and or Mutiny and being able to move from uni to a suspend function. How close is that to be done? Well, first of all, Ali, please go to the GitHub issue and there probably already is one, but please vote up, add your use cases on it. That would be very useful. B, I'm still unsure about the full support of coroutines inside GraalVM, which is the native image compilation.
So I can answer that. That doesn't work yet. Okay. It's a native compilation issues where it's for loops with multiple entries. So
does it work in VM mode?
In JVM modes, there is no problem. Yes, it works very well.
He means Quarkus and coroutines for Kotlin.
Yes. And it's actually the same for Loom in native mode. Well, I didn't try, but I believe we will have a lot of native compilation issues first.
Okay.
about Mutiny to a suspendable function, the good news is that there is a Kotlin support a mixing. So the idea here will be to add some method to the uni and multi-type for Mutiny. We are going to see them to make them or to make some operations suspendable. So that's where we are at the moment. I didn't try recently, so it's something you will need to add yourself. But yeah, that's the idea.
Okay. All right. So enough question about non-mutiny related stuff. Let's show mutiny. So again, for people that are a bit unfamiliar, it's a bit like Eric's Java, or a bit like completion stage plus the equivalent if you return more than one result. And I'll probably share your screen, Clément.
Yeah,
And you can
just click. Just let me know if you see my
Yes.
screen. Okay.
No, but let me fix that right away. There you go. We see your screen. We see the main method.
Oh yeah, great. So let's start with the basics and the main
Demo done.
methods.
Awesome.
Okay. So the first thing is why we wanted to do Mutiny. So as I said, we wanted to avoid callbacks because while they are expressing the event driven ideas behind non-blocking I/O, it doesn't compose well. On the other side, you have reactive extensions and reactive extensions implementation like RX Java or reactors. They are great. They have a lot of different operators. And the tricky thing is that very quickly, and we have looked at that over the last 5 years, your code is not necessarily readable in the sense that it generally ends up as a forest of a jungle of map and flat map, and it's very hard to follow what you are doing. And actually, a lot of developers don't really understand what flat map means and how it behaves. And when you start discussing with them, you say, "Oh yeah, but it's not flat map you need; it's concat map." They say, "Oh, what's the difference?"
Yeah,
And
so just people just say +1 if you know what flat map versus concat map means, and I don't know, +2 if you
without
know
checking the documentation.
without reading the doc, and then -1 if you don't know what it is, and then let's say 0 if you know the difference between map and flat map. There you go. I'm -1 by the way, so no shame.
So now, yeah, the tricky thing is that to use those libraries, again, which are very, very powerful, but to use them correctly, you need to have a deep knowledge into them to really read the doc, understand almost, I won't say all the operators, but at least 100 operators, so the main operators. And it can be hard. And the tricky thing is, if we are working in a team, even if you have the knowledge, well, what about your coworker? If you write 3-chain flat map, will he understand what it means? So that's the kind of things that we have seen over the last few years. And actually, the same question as Emmanuel just asked, I have asked in several conferences or even customers and things like that. And I've been surprised by the answer and say, "Oh, yeah, you're running in production? Okay, yeah." So it can be quite complicated. You really need to
And
look
some
the
people
doc.
say read the doc, but I think these are fundamental operations, a bit like if you had to read the doc for if and loops, right? Okay,
Exactly.
I'm pushing a bit the limits, but that's how I feel it is.
So
But
All
he
right,
said,
show us. Yeah, go ahead, Max.
I'll just say that most here said -1, so maybe we want to cover some basics.
yes, I'm going
Just
to do that.
yeah. Okay, got it.
So, and the idea behind Mutiny is to really to try to build a reactive programming library, which was not really an implementation of reactive extensions with all those map and flat map operators. To provide them if you understand them, but provide alternatives that we believe are exposing more expressiveness and easier to read and to understand your code. Mutiny is based on the idea of events, and it's really an event-driven library. That's another big difference with the other libraries. So here in my code, the first thing I'm going to do is retrieve a uni from a stupid and dumb service that I've created, which is named greetings. and let's say Clem. Okay, so here I've created retrieved a uni from this service. A uni, it's an asynchronous construct which will receive events. And uni can have two types of events: on item, which means the result, or on failure, which means that there is a failure and you need to handle the failure. So greetings is just saying hello, Clement, something like that. And when I get this item, I want to transform it and say, I want to just do uppercase or something like that. Obviously, you can have failures, and when there is some failures, you can say, okay, I just want to return hello, something like this. If I do this, nothing happened. Even if I execute this, and I can show you, I can execute this, and nothing is going to happen. The thing is, and that's the big difference with completion stage, if you use completion stage, is that uni is lazy. In the sense that if you don't say, oh, actually, I'm interested by the results, nothing is going to happen. And to do this, you need to do subscribe and say, for example, subscribe with the item, and then I'm just going to print it. So by doing this, I say, okay, I have my uni here, but I really want this these items, and just print it. So if I rerun this, I should have hello Clement in uppercase. So obviously here you can also handle the failure here if we have any failure, so something like that. But we don't have any failure here, except if, for example, here I just do boom, whatever. So if I do this, so if something bad happened during my event processing, it's going to fail, recover with the item hello, that I will print it. If I don't have this line, it will just go back to print the stack trace that we have here.
Dust under the carpet.
Yeah, exactly. So that's a little bit how it works. So we have this idea of items that of events that you see here, and your events are flowing inside your system. So obviously, when you have an items, you can do multiple things like transform it, just having a look at it like a peek, delay it, for example. That's mostly for tests. Fail. You were not expecting some events you want to fail, or training some other asynchronous operation. We are going to see that in a few minutes. And producer streams, we are going to see that, and so on, and so on. So uni is great for asynchronous operation. It's really mapping an asynchronous operation. And something to keep in mind is, thanks to this subscription pattern we have here, we can actually cache the uni here and call it multiple times. While here it's going to answer the same thing, the same response. But the idea here is that actually by doing this, you can eliminate a lot of the execution time, and we are going to see that in details in a few minutes. So uni is great for this, but in Mutiny there is another type.
What's more extra info about uni? Uni can return null.
Yes. So you can have. Actually, let me do this. Uni of void is actually quite common. It's something like you have an operation that completes but does not return anything. So like a flush operation and so on. So, and you can create a uni of void like this, or you can actually have our uni here. And oops. And I don't care about the result and do null. I can return that. And I need to subscribe with, and here we'll get null. So, and it's something, And it's something that if you are familiar with other reactive programming library, might look a little bit weird because they generally forbid null. In Mutiny, for the uni type, we accept null because null is part of the Java language, and yeah, it's there. We like it, we don't like it. That's just there. So, and uni of void is actually quite common. So here
remember, Quarkus is here not to, well, it's opinionated, but we try to reuse a lot of the programming models you know of, and for example, Hibernate. And Hibernate, for better or worse, in JPA, there is a way to say, fetch me this object, and if this object doesn't exist, it returns null, right? And so that would be a perfect use case for that one, for example. By the way,
So,
Clément, while I've
yeah.
got the mic, Clément says, will you be talking about Kafka? Probably not that presentation, but we can definitely try and queue a Kafka subject for later. That would be too much for today.
I will show a little bit of Kafka, but
Okay.
it's not going to be much about Kafka. I will see how Mutiny and Kafka can work together.
So Clement, just before you go, I just saw these lot of -1s about people maybe not fully getting the difference here. But so why is this good? When I look at this code, it's like, okay, that looks sensible, but that looks similar to what I've seen in the past too.
Well, in the past, it would be something like, I cannot even write it in RX. That would be something like map. So as you can see, we provide it, and then I don't have the equivalent on failures. So that would be in RX. That would be on error recover with or something like that. And the tricky thing, and we are going to see that when we are going to chain asynchronous operations, what you end up very quickly is a chain of flat map. So a flat map, basically, it's you get an items, you are going to call an asynchronous result and flatten the results.
Hey,
So
let me inject something. So Frank asked something, which is using Mutiny from JaxRS resource with the context, so just e.g. security, will it be propagated? And the answer is yes. We have something called context propagation that will do that work. And that ties nicely with another question by the same person that says, have you measured the overhead of Mutiny as a library put on top of the underlying vertex? And right now, the context propagation is an expensive proposition compared to the rest if you do very little. And that's something we're exploring into optimizing. Is that a fair summary, Clément?
yes, exactly. So of course, Mutiny and the Mutiny clients add a little bit of a little cost on top of the pure Vertex API, but you get it as an expressiveness and avoiding the callbacks, nested callbacks. Context propagations is an expensing operation at the moment. We have ideas to reduce this cost, both in Mutiny and both in context propagation. So it's two leads that are converging. It actually can be disabled. So if you disable context propagation, then you don't pay that cost. However, don't expect your security context to be propagated in that case, because it's not. But yeah, so that's more or less how it works. I'm going to explain how it's integrated in Quarkus. Just once I have shown the second type, which is multi.
If you stop, interrupting me, maybe I can go to answer
maybe
one of
I
your
can
questions.
show you the multi type. So a multi is a stream of data. So uni, you can have either an item or a failure, and the item can be null. On a multi, you can have a stream of data, potentially empty, so potentially none, or failures, or the completion signals. So let me show you this. So let's imagine, what is the name? Source dot get source. So that's just, I can't remember. It's a random, it get random number every second or every something.
So
every
it's
what?
part of
Every
your testing
100
environment,
milliseconds.
or yeah.
Sorry?
Source.getSource, it's something you for your
I
testing environment.
just made it before right before the.
Yeah, imagine it's a Kafka message returning a double, and then you start from there.
Exactly. So here I can do, well, the same kind of operation. I get my double. I can, for example, convert it. I don't know, something like that. And then it's the same thing. I need to subscribe and and, for example, and print it. So it's mostly the same thing. And in the multi API, you will see that we have on item, on completion, on failures. There is this on overflow, which is related to back pressure. I'm not going to go too deep around that, but basically on multi, we implement reactive streams and the back pressure protocol that is specified in reactive streams. Sometimes you have sources of data that does not respect this back pressure. So you have this on overflow, which is an event and a mutiny sense, where you can do things like drop buffer or drop previously items. But the API is very similar to the multi one, and that's the whole idea in the sense that you are reacting to events, and events are items, failures, and completion in that case. So we get our items here. And as you can see, there is multiple items in a multi.
There is one question from Ashish. How can you call multiple methods in parallel and merge the response?
Yes, with an on item produce uni, and yes, that's actually something that is related to our flat map discussion, and I'm going to show that in a very real example, because that's just to explain a little bit the two types.
Yeah.
So if we switch to Quarkus, most of the Quarkus APIs have a Mutiny support. And typically today I'm going to use Mongo with Panache and the reactive facet of Mongo with Panache. So you already have an insight about Panache. I think it was last week or the week before. I can't remember.
Not Mongo with Panache, but it's
with Panache.
At some point.
Yeah, Mongo with Panache is the same idea in the sense that you express your structure here, and you don't have to do any Mongo-related operation. It's going to be done for you, and you have the same model where you can have static method. And here I'm just getting some. Oops, I wanted to show this one actually. Getting a random villain and a random hero. So here we have two APIs. We have this one for villains. So as a French, I cannot pronounce these words correctly. So let's say the bad guys. So that's the bad guys. So when a bad guys, or when we want a random bad guys, we go to the collections. We get the number of documents. It's Mongo, so it's documents. We are taking a random number, and we are going to retrieve this the chosen bad guy. So for this, I'm going to use find all page and so on. So this is actually a Panache that gives that. What's interesting here is this produce uni here. So basically it means I retrieve the number of documents. This is an asynchronous operation. Once I got the result, I compute the random one. So I picked one. Okay. Once this is done, I'm retrieving this bad guy from the collections. So this second operation is named onItem produce uni, because onItem you want to execute some asynchronous operation that retrieves something. If we look at heroes, and if you are familiar with reactive programming, you will be familiar with this, because that's the same code using map and flat map, where you have map and flat map. So on uni, map is onItem apply, and flat map is onItem produce uni. So they are shortcuts. So now if I go back to my...
So by the way, I don't know about you guys, but maybe that's because I don't use reactive, every day, but map and flat map always escapes me. So at least the onItem produce uni and onItem apply is clearer to me than map, flat map, and the flatness of for example, the alternative APIs.
So we provide them we understand that there are common operations, and some people understand them and can handle them, but there are actually just shortcuts over the produce uni and apply and things like this. Okay, so let's see how it's integrated in Inject CRS, because as I said, most of our APIs have support for Mutiny. So if I want a random hero, so the good guys, okay. So here I'm going to return uni. Yep. Hero. And here, well, because Mongo with Panache is doing everything, I just return my random hero. And I should have my, yes, subservice is working. So if I do this, I should get a hero. Yes, so the good guys from the database. So typically here I got kick-ass, level 3. That's a picture and some IDs. And if I do another one, that's Superman, and another one, Icon. Oh, I didn't know that one, and so on. So I will do the same thing with Villain. So the bad guy, up. And now I'm going to try this. And yeah, Mephisto, I know that one. Anti-spawn, that's an anti-thread things. You cannot spawn. Fedza and so on. So there is also an integration with multi, and actually it's mostly used when we produce streams, so SSC. So we can do something like this. Multi of heroes and oops. And I said that I wanted a SSC, so produced media type. And oops. Oops. What? I can't remember. SSC element type, sorry. Media type, .json. So basically it's an SSC of JSON. That's what it means. And here, let's say I want to retrieve a hero every second, so something like that. I will create a multi, create from ticks every, I said of second, 1. And every second, I want to retrieve a hero, and I'm going to call this get random hero. So here it doesn't work, because while this could work on this will work on uni, it doesn't work on multi. And the reason is that this is actually a real flat map. And in flat map, there is two parts. There is the map that we have here, produce uni. We produced an asynchronous types here, uni. And then we need to define how it's getting flattened. So do we want to concatenate? Do we want to merge or merge with concurrency? And we just got a question about that.
Yeah, so let me what's the difference between merge and concatenate?
So let me try to illustrate it here with comments. Imagine that you have the stream A, B, C. Okay? That's your stream. A followed by B followed by C. If you have an operation which is asynchronous, which will produce for A, for B, B, and for C, C. So far so good, it's just doing an uppercase. But it's an uppercase which is executed on a remote service, something totally asynchronous. So you don't know when uppercase A, uppercase B, and uppercase C are going to be produced. So if you merge, you can get as a result B, C, A. Because maybe the operation to produce the uppercase A has been slower than the operation to produce the uppercase B and C. Think in the cloud where you have multiple instances of your service. That is likely to happen because one of the instances might be a little bit less loaded than the other one, so you can do such kind of things. If you use concatenate, you enforce the order, and then you can get A, B, and C, because that will keep the order from your input stream. It's not only this. Merge can actually execute the 3 operations concurrently, because it doesn't care about the order. So it will say, okay, I will start the operation for A, for B, and for C, and as soon as get something, I will write them down. For concatenate, it's not that simple, because you want to preserve the order. So I will execute for A, and when I get the answer, I will then execute for B and then for C. So while here it's actually in concurrently, here it's going to be sequentially executed.
Okay.
So why is it called concatenate?
Looking at merge to run stuff in parallel.
So why it's named concatenate? Because basically this is not doing this. This is actually returning a stream of one element like this, and you just concatenate the streams. That's why. I understand the name is not. It's actually a name that I've picked from the other reactive programming library. I don't necessarily like it that much. I'm actually trying to find an alternative, something like preserve ordering or something like this. Obviously, in the merge operation, you can express the level of concurrency you want. And if you do this, well, you're likely going to have a concatenate, because basically it will call A and then wait for the answer, then call B, wait for the answer, call C, and so on. By default, your level of concurrency is, I don't remember. Check the documentation, it's written inside. That's for sure.
Higher than 2.
Yeah, higher than 1.
Yes, that's for sure.
Got 2 questions. Can we return paging results in as multi? I believe the question is for the Mongo panache, which I don't know. But that's an interesting question. So we're exploring the same subject for Hibernate reactive, so for JPA, and that's actually a more complex question than anticipated. So just saying, hey, let's abstract stuff as multi is not adding that much value over just doing the pagination. But as soon as you have a multi, you can do what Clement just described, concatenate or merge or things like that. So that's where returning a multi of the results would be quite interesting in that model. So we're literally asking ourselves that question, and it's very likely going to show up once everybody's happy with the API. Having your feedback would be quite good.
So actually, the question is, when you do paginations, you can see 3 things. You can return a list of pages of items. In that case, because it's a list, it generally forces you to load the complete collection, so the complete set. So you're likely not really, you don't really want this. So if we discard the first one, then we have the second one, which will be a multi of pages. So basically, you return page of items. And because it's a multi, you don't need to load all of them, but there is, again, the reactive streams protocol behind the scenes, so you can retrieve them one by one as soon as they are requested. That's probably the best model. And if you want to switch to a multi of items, you can just flatten, actually, the items from the page inside the resulting items. Or you can return directly a multi of items. If to just react to what Emmanuel said, for most databases, it generally makes more sense to use this second approach here. Why? It's because there is some kind of cursor or batching or things like that. So a number of items you can retrieve in one batch, which will be your page, more or less. And that's what makes the most sense. And then in terms of API, you can decide to go and expose the page or flatten these items into a multi.
Yeah. The other aspect is you could use what is called a scrollable, a cursor to the database, but it's a bit unclear how common that usage is, and it does require to keep that up and open? Is it really what you want, even if you're in a non-blocking universe, considering the database might or might not be, blocking, and the actual protocol allows you to have more than one query in parallel. So all of that is very immature on the database level, to be honest, or the classical RDBMS at least. So that's one aspect. Hold on, I do have another question for you if I find it. Oh yeah, quick one. So Clement Viret asked, could we execute concurrently but have the result in order?
Concurrently and have the order in
He wants
yes.
to take and eat it.
Yeah. So actually, it's not. It's a little bit different, and I'm going to show that in the next class. So
Okay.
be patient. I'm going to use what we call combinations, and you will execute concurrently and get the results in order.
Okay. Another question is, would you recommend using reactive routes instead of JAX-RS with Mutiny? Because the Mutiny stuff would run a JAX-RS worker thread, as far as I understood.
Yes. So at the moment, and that's important, at the moment, it runs on a worker thread, where reactive routes does not run on a worker thread. So there is two works that are in progress right now. The first one is to try to see how we could run JAX-RS endpoint, non-blocking JAX-RS endpoint directly on the event loop. And in that case, we would not need the worker thread. And the second work is to provide a better integration between Mutiny and reactive routes. And this is going, well, hopefully in Quarkus 1.7. Yes, 1.8 is right now, so 1.7. So the next one.
Great segue for me to show the roadmap. What you're seeing right now is the SmallRye Mutiny website. So type SmallRye and Mutiny, and you'll find what you're looking for. If you just type Mutiny, you'll get lots of other sites. If you do quarkus.io/roadmap, it does redirect to a GitHub project with our plans. And I repeat, these are plans on what we want to achieve for Quarkus 1.6 and when it's landing, 1.7 and when it's landing, and so on. So here in 1.7, there should be what Clement is talking about, which I'm not sure it is actually.
I believe it's in the reactive roadmap. Still need to copy that over.
These are the big subjects, and sometimes not all of them are shown here. Okay, and yes, the other point is, if you still have blocking APIs and therefore will rely on the worker thread, then it probably is fine and okay to use rest easy in that situation versus going for the reactive route and Mutiny in a fully non-blocking fashion. Let's say use classic Hibernate. That here you will have to do the jump from one thread to another anyway. So that's where the question is really asked. Is like, what are you always using non-blocking library? Therefore, the answer that Clement gave is right. If you're using some blocking APIs, then the answer might be a bit different.
So something I forgot to show here, but I can actually show it here, is that it's not because you get a uni. So uni is by default non-blocking, asynchronous, and so on. So you get the events. But sometimes you want to switch back to the blocking world. And to do this, you can do await, and definitely, or at most, or something. So you indicate timeout, and then you get your hero directly. So that works. So you can also use Mutiny API in a blocking code using this await things. We have equivalent for the multi things to get some blocking iterable or things like that. And I had a question about Loom at the beginning. This actually is not blocking the carrier thread, so you can already use Loom with this, and that would work out of the box. And our idea for Kotlin coroutines is actually to add a mixing around this.
Okay.
So, but I wrote this code, but I still don't know if it works. And because I got interrupted a few times, I'm now a little bit skeptical. So let's try to see if it works. So normally it does not work. Why? Oh yeah, forgot the pass. So normally every second we got a new hero, so that works. So that's basically how it works. So every ticks, so we have a first stream that every second emit a ticks, and for every ticks we get random heroes, and we don't care about the order, so we just merge. I could do the same with concatenate, which in this case I don't believe make a lot of difference. Let's see. No, both works, but yeah, we don't see if it's interleaved or not. So, another thing is, you see here, I don't subscribe on my return uni and so on. The thing is that it's Quarkus that is recognizing uni and multi and doing the subscription and the right things for you. So in this case, you don't need to subscribe. It's just going to work. Yeah, I think on this, yes,
that's Quarkus is interesting because it mixes the nice stuff you got from the imperative style framework where a lot of things is declarative, but here you got the reactive aspect where when it matters, and then we do the wiring, some of the wiring for you.
So another thing, as I said, so we have almost everything in Quarkus that is integrated with Mutiny, and typically we have the microprofile REST client, which is integrated. So you can return uni, or I think multi is not supported yet, but uni at least is supported. And that's typically the microprofile REST client for for the API we just built. So if I go back here, so now that I have good guys and bad guys, I want to make them fight. Of course, that's how it works. So I need to retrieve a hero, I need to retrieve villains and make them fight. I've injected my REST client as usual, and now I'm going to do get random heroes. Hero. And I will do the same thing with get random villains. But here, if you are familiar with distributed systems and you know the complexity of distributed systems and basically they are going to fail, so you need to have some kind of error handling here. So what I'm going to do is that on failure, I want to recover with, let's say, a fallback. However, that is not going to handle timeout correctly. What we will do here is that if no item after, let's say, second one, fail. So what I just did here is that I want to retrieve a random hero from my remote service. If we don't get any events after 1 second, then we fail. And on failure, this one or whatever other kind of failures, I'm going to recover with a fallback. I'm going to do the same thing with the bad guys. Oops, here. So at that point, nothing happened yet because no one really subscribed. I didn't return the uni yet, so nothing is happening. So I want to execute the heroes unis, the villains unis concurrently because maybe it's 2 different services, and then join the results. We just had this question a few minutes ago. So for this, I'm going to create to combine my unis, so all unis. So here we have hero and multi and the bad guys, and I want to collect the result as a tuple. And here, now that I have a tuple, I have a uni of tuple. I'm going to create a fight. So I have my tuple. Tuple dot my first item is my hero. My bad guys is my items 2 for my tuple. Okay, and now I need to call compute HV, and I'm just going to return this. And I'm going to return that, and that, yes, that works. So basically, so what I did
again is the shortcut for on item.
Oh yeah, sorry.
On item apply, right?
Yes, that's it. So I got a representation of my operations that retrieve an arrow and fall back if something bad happens, same thing for the bad guys, and then I'm going to execute both concurrently. Once both have succeeded, then I get a tuple with heroes and villains, so it's a pair, and then I compute the outcome of the fight. That's relatively simple. Of course, here you can have more than two. They are running concurrently. You can also combine with some different function. You can stop at the first failure, so fail fast or things like that.
So I've seen a couple of questions around, hey, how can I do some stuff sequential, some stuff depending on, call, that's why probably they want to do it sequential, and some in parallel, and, combine that or reactive. I think the answer is you combine those things. So unique combine or multi-combine, I suppose there's an equivalent, will let you say, I'm going to run those stuff in parallel. And we've seen how to do the sequential a bit earlier in the presentation with was it dot concatenate, if I'm if I'm not wrong, about the one that actually do stuff sequentially. Yes. So if you combine those two and chain your unis on multis, that's how you would define literally a pipeline of stuff that can be happening in parallel and stuff that can happen in sequential. Maybe that would be an interesting blog post to host somewhere, to host on Quarkus.io, Clement. That could be an interesting one.
So most of those answers are already in the Small Y Mutiny documentation, but yes, we can write a blog post about that. So the Mutiny documentation is use case based. So you say, how do I run things sequentially? How do I run things concurrently? And you will see all the different codes. And you mention it, and I say, hey, by the way, I have a different way of writing that. I can say, run hero and villains, and when both are done, then get my tuple and so on. So that's exactly the same thing, except that this is an instance method and not a static method. Okay. There's nothing interesting in compute fight outcome. It's just doing some random stuff. I love random, as you can see. Everything I do is based on random. But now, if I go back...
We're 1 minute over, so...
Yeah, I just want to see... the last thing... I hope it's going to work. Yes. So that's actually what we just built. So the endpoint we just, so this fight is called from the fight service and exposed here. And you can actually run fight. This is already on GitHub, but if you go to my GitHub account, you search for Mutiny demo, you will see this code, and you can try that. We had a question about Kafka. So actually, if I go back to the fight service here, what I'm doing here is that send the fight result to Kafka using a reactive messaging. So that's simple. There is nothing related to Mutiny actually here. I'm just sending using the emitter. But on the other side, in the stats service that computes some stats, it's actually getting the Kafka records as a multi and processing multis and so on. So it's already integrated. And this is a stupid way to compute who is going to win heroes and villains and things like that.
Okay.
Yes, that's more or less it.
Thanks, Clement.
Just can I just summarize? So what I got from Mutiny here now, I think like the third time I've seen you explain it. So I get a new thing every time. But is it more than just? Well, I think it's a good thing. It's basically simplifying the Fluent API or reactive API, and that's it, right?
A readable API.
That's what. A readable API.
It's a Fluent API for reactive operations that is not intrinsically event-driven. So I really wanted to show those event-drivenness inside the API. And the reason is that it's been designed around the idea of distributed systems where almost everything is asynchronous because, well, it's distributed, it's over the network. And using events make things, at least for me, a little bit more easier to understand because of failures, because of a timeout and things like that. So you don't need a circuit breaker here. You can express everything inside with a Mutiny API and such kind of things.
I definitely like it. So, but I thought Mutiny. First when I heard about it, like there's something else to it, but I like the beauty of the fact that it's just about you basically take the reactive API, and make them readable in its own way. And then as a bonus, you get this bit more expressive power for failure and that kind of thing. So that's
Yeah.
really nice.
And something we didn't show is that it's very easy to go from Mutiny to JaxRS or completion stage and things like that.
Not JaxRS, Reactor
Sorry,
or Java.
yes,
Yes.
Eric's Java. One of those
So
Erics.
so we have converters to go back and forth these different libraries. So it's already integrated. We have started looking at how it's going to be integrated into Loom. I already mentioned it a little bit, like with this await and on a multi, you can do something like files.collect, not subscribe as iterable. And actually, this is a blocking iterable, but this is not blocking in Loom. This is not blocking the carrier thread. So it's actually been designed around this idea already. So you're almost ready for the futures. There's still a few things to tweak and tune, but we're almost there.
Yeah, try it in Anger. If you got the energy or a side project, you want to try it in Anger. I see the Clement Birette is actually trying it for real. Please give us feedback on the API. So we give ourselves feedback, as part of the team, but, any external feedback would be hugely appreciated because we're trying to find the right balance of usability and compactness in the code, not to, especially when you chain calls that are defining your pipeline, like for it not to be too verbose. So give feedback. Go to where could they give the feedback, Clement?
Well, they can give the feedback on the Quarkus mailing list, on the SmallRye Mutiny project. So we have a GitHub project. So you open an issues on Zulip, ping us on Zulip. And yeah, all the feedbacks, all the ideas, missing operators, because we have actually selected the operators we wanted. And sometimes, yeah, like last weekend, someone wrote something and said, oh, I actually would like to have expir at and expir in on one of the operators. He implemented it. We looked at it, and yes, it's merged. So we were really taking an iterative approach on the APIs. The main debate right now is finding the right balance between having shortcuts on uni and multi, or having them in what I call groups, event groups on item, on failure, on completion, and so on. We are making progress. Nothing is written in the stone yet, so just
I got a
come.
stone eraser. Don't worry.
So yeah. So anyway, we the feedback is welcome. Ideas are welcome, and the feedback we have right now from non-reactive developers is actually good. They were able to write reactive code without necessarily being a very very knowledgeable about reactive, about all this world, which I understand and I completely agree is totally different from the imperative world. So it's already a good win for us, but we want to go a little bit further.
Okay.
And we want to innovate on the API itself, not much on the how it's managed in terms of back pressure and so on. There is plenty of works around that in Reactor, in Java. That have done amazing works, and yes, this can be just almost reused as it is.
Okay. Thank you very much.
Cool.
And sorry, people, there is a couple of questions we couldn't attend to that were a bit too specific. Just shoot the question on Zulip, and that'll be. Oops, sorry. Shoot the question on Zulip to Clement, mentioning Clement, and we can follow up on the conversations.
Or send an email on the mailing list if you prefer the asynchronous way of doing things.
Well, we never said you would answer right away.
Yeah, that's right.
All right. Thank you, everyone, and see you next time for I don't know what subject, so it's going to be a surprise. And don't forget to actually subscribe to youtube.com/QuarkusIO and show us your goodwill.
And you should find my gRPC demo that is actually related to Mutiny if you want to see how it's integrated in gRPC, because that's what we just shipped in Quarkus 1, or maybe it was 1.5.
Yes.
Yeah, 1.5.
Awesome.
All right, cool.
Bye, everyone.
Thank you.